You are welcome to today's lecture on network traffic management. We give detailed application requirements and ways of guaranteeing network performance in a network system. First of all, I would like to define network traffic management. It's the regulation of traffic into point of networks in order to improve the service that network provides with the aim of having a fair or equitable allocation of network resources for adaptive applications and for performance guarantee of non-adaptive applications. This can be achieved using certain algorithms like the leaky bucket or the token algorithms. Multiplexing in network is based on time scale such as round-trip time for scheduling and buffer management, routing datagram around congested area and feedback flow control, as well as negotiation of a new traffic profile for an existing and new client. Meanwhile, using timescale allows the session level to decide for admission control of any traffic in the network and in routing connection. It also aids in pricing to shift part of peak load traffic to peak period. In order not to degrade the quality of service during transmission of multiplex traffic, certain conditions need to be met, such as classifying and isolating the classes of flow of packets in order to protect flow of traffic from other clients and to determine appropriate services. Efficient use of resources are also considered so as to ascertain call admission to allow network to block flow if it cannot meet the flow need. These conditions will be used to determine the management strategies for connection and the connectionless service models. In connectionless service, the source marks the priority of traffic classes giving precedence to higher priority traffic. This, as a result, might overload the network with high priority traffic. Although in connection-oriented services, connections before communication are made from the source, and traffic characteristics are specified with their desired performances. And then the network checks if it can admit a new client and guarantee existing commitment based on its capacity. If it can admit a new client, then it will regulate the incoming traffic as well as renegotiate a contract during the transfer. In regulation of traffic in a network, certain regulator types are used, such as the policers, the shapers, or markers. The policers discard packets once they cannot be sent immediately, while the shapers buffer packets that cannot be sent immediately. Markers or taggers, as the case may be, marks the packet as having low priority once they cannot be sent immediately. The regulators can also be cascaded for better performance. There are algorithms that characterize these regulators, such as the leaky bucket algorithm. It follows the principle of bucket that holds packet traffic from an unregulated source and allows the packets to drip out at a constant or regulated flow rate. Another algorithm called token bucket uses token to allow packets to flow as traffic are buffered based on first come, first serve. Then let's have a look at scheduling. Scheduling determines the service order, which is the queuing delay experienced by different users within a service time. It also determines whether to serve or discard a particular customer. Scheduling can occur at the input or output port of any point of contention, and the purpose are for fair access of network resources by clients and for protection of traffic to avoid degrading of quality of service, for efficient implementation and admission control for guaranteed performance. For fairness in sharing network resources, it needs to be bounded and independent of scale, as well as account for allocation of users. Fairness can be measured based on index for evaluation and assumes that demand is elastic, thereby sharing the same network resources. But the maximum and minimum fairness provide an algorithm for allocating resources based on demand of resources which are limited. To protect the quality of service received from other overflow, the network needs to be fair and be able to regulate the traffic using the traffic management algorithm like the leaky bucket. This will then ascertain the efficiency of admission control of any new and existing client. Scheduling algorithm may be by first come first serve basis, as in round robin, or fair and weighted fair queuing, or by general processor sharing, which is an ideal case using a fluid flow model. For service to be guaranteed, it needs fair queuing or weighted fair queuing. Work conservation can also be achieved using work conservative scheme where there is no transmission if there is no packet awaiting service, or network conserving scheme where the network can be idle even if there are packets queued.